right. Welcome, everyone. Thank you so much for joining us for today's Coegi Hybrid Education Seminar, Demystifying Artificial Intelligence. All right. And for those of you who haven't worked with me before, my name is Savannah Westbrock. I'm Coegi's Director of Innovation and Development. If this is your first time with our Coegi Hybrid Education series, welcome. We are a Midwestern-based full-service digital marketing agency. We've been working with AI co-pilots for all 10 years that we've existed. We've had hundreds of experiences with brands and agencies all over the world, guiding them on how to plan their digital strategies, how to work with AI, how to make smart optimizations, and how to have that human oversight over AI as well, which is really what brings us here today. So our conversation is going to be focused really in two different areas. So first, we're going to start with just contextualizing recent AI developments alongside broader tech development. So as I've said, we've been working with AI for over 10 years, but obviously there's been a lot of conversation in the news in the broader space about more recent AI developments. We're going to help you differentiate those tools, explain how they work and how you should be using them, and also give a little bit of advice for those of us in management, in leadership, who are looking to upskill their staff, who are looking to talk to their teams about how to use AI responsibly and how to build some of those frameworks internally to make sure you're set up for success with the next batch of AI updates that are likely to come. But this conversation is really intended for marketing professionals. So if you are a computer engineer, you're going to find this is very conversational. It's very high level. And we're doing that on purpose today. My goal was to make something that I could send to my parents or my grandparents, and they would be able to basically keep up with what I was saying. So some things are going to be really left to like metaphors and similes, but overall, our goal is really for everyone to walk away with that context, the vocabulary that you need, so that when you're reading all of these AI updates, when you're sitting in vendor presentations, you have that greater knowledge of artificial intelligence. You can be that internal resource for your clients, for your peers, or for your leadership team. All right, so before we kicked off our recording, we had our early joiners take a quick quiz to see if they could just tell if something was generated by AI. So I'm going to speed through this. If you weren't able to join it, highly recommend checking out the Washington Post's quiz on Gen AI, where we've pulled a lot of these images from. So what we've seen is that AI can create real estate listings that sort of pass that sniff test. They can create images in a lot of different styles. And they could even create a brand and a logo, a slogan that all seem to be a cohesive picture, something that we might make in those early marketing education courses at our universities. And additionally, zooming a little further out outside of the marketing realm, just images and texts, we're seeing audio and video start to pop up that was AI generated. We've even got celebrities like Grimes saying that she would share royalties with anyone who's used her voice to make an AI generated song. Although important to note, about a month later, she walked that statement back. Once we've really started playing with these tools, something tells me her legal team said, hey, that's actually a terrible idea because once someone has your voice, they can make it say anything. And that has really shifted into the larger AI conversation. So we've seen deep fakes of celebrities' voices in documentaries, or, Carrie Fisher's likeness in recent Star Wars movies after she's passed. We've seen misinformation start to spread and be attributed to candidates all over the globe, including our own. And we've also seen AI tools be used to breathe new life into old phone scams, this time using someone's actual voice to try to defraud other people. Additionally, we're starting to understand how this AI might affect our larger economy. So things like our writers and actors strike in Hollywood has made a lot of headlines, but additionally in the marketing world, we're seeing a lot of uncertainty about how many jobs might be made redundant due to AI tools. We're seeing an increase in tech companies looking at their teams and their staffing and making changes there. And what all of this has led to is really a compounding AI anxiety that's skyrocketed, especially for marketers. And this was really the catalyst for why we built this conversation for our internal teams. We've seen the sentiment of leaders and frontline employees has differed really sharply. So this is some research we've pulled from the Boston Consulting Group that surveyed people across multiple countries and multiple fields and said, what is your optimism and what is your level of concern? And part of what we noticed was that there's this large shift between frontline employees, between managers and leaders on that amount of concern. We've seen anxiety at its height among those frontline employees, and people in marketing in this report had a 42% of their staff saying they had some sort of concern or anxiety about the future of their jobs based on AI, compared to a 22% baseline. So that really stood out to us. That made us realize we need to start exploring this anxiety, having those conversations with our Coegi staff, trying to understand where that anxiety is coming from and how we can responsibly move forward as these AI tools advance, whether we bring them into our agency or whether our platforms bring them in and we're catching up to those advances. And from surveying our own staff, we realized a huge amount of this anxiety, the height of it, was really coming from staffers under 25. And that was consistent with what was in this research report as well. So from that, we had a larger conversation and realized that a lot of this anxiety is coming because generative AI, this entire conversation we've been having this past year, happens to be Generation Z's first lived major tech revolution, right? So these staffers have always had the internet. They're used to having smartphones update every year. They don't really have any tech revolution to compare AI to in their memory. So shifting forward then, making sure our staff feels comfortable to experiment, to test and learn with some of these tools, we wanted to address this AI anxiety through some education, some experience with it, and really just adding that context. So what we're going to do today to start, we're going to zoom out a little bit. We're going to try to paint a picture understanding how artificial intelligence has developed over time alongside those other tech revolutions that have shaped the world that we live in today. And we're going to answer some of those questions that have been bubbling up, not only from our staff, but also from our clients, where, hey, Gen AI has burst onto the scene out of nowhere. Why has that happened? What can we do to responsibly test this while it's still developing? But additionally, part of that anxiety comes from just unfamiliarity and not knowing how these tools work. So we want to explain what they can do and what they can't do. And then also make a few predictions on expected changes and how we as marketers, we as business people can experiment with these tools responsibly. So kicking off an abbreviated history of how we got here. And we're going to zoom way out in the beginning and just level set on what even is artificial intelligence, because we've got a lot of conversations happening, all throwing this word AI around. We have an entire league of sci-fi information out there. But really, when we start to have this conversation and start to understand these tools, it's important to back up and keep in mind that at its core, at its highest level, AI is a theory. It is a discipline within computer engineering that has a goal in mind of creating something that can imitate human intelligence, that can problem solve at a level similar to human beings. So it's based on that notion that human thought processes can be replicated and mechanized. And that question, that theory of can this even happen, is really as old as questions about what thought even is. Right? So our timeline starts way back in like the 17th through 19th centuries as philosophers question if machines could ever learn how to think the same way a human being could. And those questions allowed imagination to take off. It allowed fiction to really blossom, right? There is a super machine that we could point to in Gulliver's Travels that would be considered an example of AI today, right? Early film in the 19th century introduced us to smart robots or mechanisms or other things imitating human cognitive processes, and made predictions on what that might change within our greater society. But really, zooming forward to about the 1950s, this is where our current understanding of what AI is starts to develop. That's where the term comes from. It's when our first AI programming languages started to blossom. It's when we had logicians, mathematicians, philosophers, even, and engineers all coming together to question, okay, we have these computers now. What can we do with them? What future do they have in terms of intelligence? We've got some fun stuff during that time of trying to program a computer to play chess and realizing, oop, we're not quite there yet. That's way too complicated, but we can teach it how to play checkers, right? A bit like playing with a 9-year-old. Similarly, some of the things that would shape the future of science fiction and the future of the conversation today blossomed during this time. So Alan Turing published The Imitation Game, which we today refer to as the Turing test. And again, it's with that philosophy in mind, those questions of could this happen in mind, that this test should be used. If you're unfamiliar, it really posits the question, could a machine ever convince a human being that they were engaging with another person instead of a machine? So you'll see that pop up all over science fiction. You might even see it pop up in the news as we talk about chatbots today. And it all goes back to those early conversations computer engineers were having with each other in the 50s, which really developed based on the world wars that were concluding at the time of the 50s. Really, the history of AI, the history of computers, and the history of military funding go hand in hand. So a lot of the reason we were able to start moving forward with this development, this engineering, came from the fact that we had a very dire interest in advancing the allies technology as quickly as we possibly could. And some of that continued as we shifted into the 60s, into the 70s due to Cold War funding. We had a different goal in mind, in which case to get to the moon. But once that space race was run, we really saw the funding shift from, not just military applications, but those larger questions of what other types of intelligence could we maybe tease out of these computers we've built thus far. Some fun stuff got built around that time. Eliza is a very famous example of an early chatbot. Our staff has called it ChatGPT's unimpressive grandma. Some of those language models start being built along with, very basic logic, not anything we would refer to as a large language model today, but some of the building blocks began to be laid during this time. And video games started happening here too, right? Pong burst onto the scene, I think in the 70s. So around this same time, engineers all over the world were looking at their fun money, really, and questioning, okay, what else could we do here across, universities, in their own garages, anywhere they had access to the technology. But the story will repeat a few times. Funding pressure really started to affect and mold the future of computers. So after the conclusion of the Cold War, or the period we classically think of the Cold War, a lot of that government funding that came from the world's militaries began to be reallocated to different priorities. So that funding pressure started to divide those engineers into two camps of, okay, if we only have enough money to build one big idea, which path should we take? And those two camps were loosely divided into people interested in pursuing artificial intelligence and people interested in pursuing personal computers. So let's break down that question, right? Do we fund mainframes and AI, or do we fund personal computers? So over on the mainframe front, their perspective, their opinion was they should focus their resources and their time and their energy on building a single sort of super intelligent mainframe that could be replicated and given to very specific use cases, things like universities, maybe libraries. Military usage was certainly still very important here. The goal was that it would initially be paired with some sort of operating staff, technician, some sort of very white collar type of job in each of these places, training people how to interact with the computer, but with the ultimate goal of getting that AI strong enough within this mainframe that you could speak to it like it was another person. So sci-fi examples are really helpful here. Think anytime you've ever heard someone say, like, computer, set a course to this planet. That's an example of a mainframe. For our younger viewers or people my own age, Karen from SpongeBob is another helpful example of a mainframe. It is a giant computer that you speak to, and it speaks back to answer your question. We've called out here that the US and the UK militaries are really the ones who were in this camp encouraging their people to build this type of technology. And part of that is the pressure in just general global society, right? This technology is very new. It had helped these countries in very specific ways throughout global conflicts. They wanted to keep that technology a little bit closer to the vest, keep it closer to home, alongside the other tech that was developing out of that military intelligence at the time. Like the very basis of the internet really blossomed along here as well. But over on Team Personal Computer, the team that really won out, they wanted to shift that philosophy into something a little bit more democratic, right? We should build computers that are simple enough that they just support our everyday human life. They are tools instead of a super intelligent thing on their own. This camp really won because, again, that funding, that money, that private industry interest really took off here. And it was just something that the general public got really excited about worldwide. It allowed us to stop differentiating necessarily between AI or PCs. It allowed us to give more of a hardware focus on small, simple, cheaper hardware to build than a full mainframe, while allowing AI and computer technology to develop within those tools. So as we shift into the 1970s, that decreased budget coming from the government, coming from the military, meant that there was a shift to private funding of things like AI. We didn't necessarily refer to these advancements as artificial intelligence at the time. There wasn't that language outside of the people actually building these things. It truly was, what can computers do? What can machines do? But when we look back, it's easy to see some of these things as milestones along the path of AI that we're walking today. So in the 70s, we start to see smarter machines pop up from factories like GM that started to build movable arms that could make their factories safer. We start to see those university professionals that had previously been collaborating with the military look to private industry and say, what can we do? What challenges do you have that we could potentially use a machine to solve? So they start to build things like cameras that could smartly track motion of an actor across a room for Hollywood. And then as we shift into the 80s and 90s, we see an arcade boom. We see video games really start to take off. We cannot separate the history of video games from the history of computer science. They're so closely linked. And again, we don't really think of AI and arcades in the same context, but when you compare something like a Pac-Man ghost that's intelligently programmed to chase a player, to respond to a player's action, compared to something like Pong, it's really clear to see how that tech had advanced and gotten smarter. Similarly, driverless cars are something we think of as being a very modern invention, but Mercedes-Benz back in the 90s had a driverless car that was smart enough to go up to 55 miles per hour on a closed road. So the question sort of became, all right, how much is this going to impact our bottom line when it comes to private businesses funding some of this advancement? But it definitely kept the technology moving as we prepared toward the next big public government interest in computer science and AI, which I would mark at 1997. So those engineers way back in the 50s who were trying to teach a computer to play chess in the decades since had not only taught chess play successfully, but did it so successfully that in 97, a computer was able to beat a human chess grandmaster for the first time. And for those of you who are experiencing a little bit of that AI anxiety now, this is a case where it's really helpful to look to the past and see how the public responded to this news. Because we saw a lot of the same conversations and a lot of the same headlines we're seeing today, right? People very validly questioning, how smart is this technology going to get? What is the impact on my daily life going to be? And that conversation in the 90s was also spurred on, of course, by the approach to the year 2000 and the conversation surrounding the Millennium bug. Now, when we had this conversation internally with our Coegi staff, we realized a lot of people didn't have a solid memory or any real understanding of what the actual panic over the year 2000 was in terms of the computers. We've seen a lot of memes, a lot of jokes in the 2010s. Looking back on it, it's sort of easy to maybe laugh and think it's silly that there were genuine fears about computers taking over the world or at least crashing the economy. But that really, it doesn't fully take into account the hard work and the massive amounts of overtime and the collaboration across businesses, across industries, across government to reprogram a lot of the things we had set up and built into our banking systems, our stock trades, our airplanes, even, and air traffic control to make sure that when that year 2000 hit, things were not going to break. Right? It was a very genuine fear. So in the early 2000s, the real start of the millennium, not only just having a computer in your house or at your place of work, your schools became more doable, but the internet access became more reliable and more accessible to the average everyday person. That brought with it internet access and a lot of development in many different avenues. So we can look back and think fondly of a lot of dot-com sites. Of course, the dot-com bubble burst, we don't really have time to get into here. But in terms of just how the public was using a lot of these tools, we saw hardware explosions, things like cell phones and then smartphones developed in a really short amount of time. We start to see some of the tech giants that continue to exist today growing. So Google, Facebook, Amazon pops up during this time as well. And then as we shift into the 2010s, it's wild to see and to think about what caused panic in the 90s versus what we had in 2010s, right? So IBM Watson, famously the computer that won Jeopardy in the same year that Apple introduced Siri. When you compare that and think back to, basic chatbots, computers that couldn't even figure out chess, this all happened in such a rapid amount of time, and it's not surprising that it led to a lot of money. So in the 2010s, we really see that Silicon Valley boom happen. We no longer have that funding problem that has plagued the development of AI in the past 40 years, right? We've got companies now saying, okay, we're willing to give you some money up front. We're investing in you so that you can develop your technology from here. And that led to a lot of development of the hardware, software, the websites we have today, and the tools we use in our workplace. But it also reignited a lot of interest in the theory of artificial intelligence. Got a lot of these companies thinking, how can we not only advance our computer product and the tangible things, but the intelligence that powers them? Can we truly build something that is going to pass that famous Turing test? And really that brings us up to October specifically. So that question of how artificial intelligence seems to have just exploded out of nowhere into our news coverage really kicked off with OpenAI debuting ChatGPT. But that still doesn't quite answer the question of why now exactly. And this is active history, so it's hard to fully nail it down. But if we are going to present a bit of an editorialized theory for you, you have to think about all of that context I just walked through alongside just the past 2, 3, 5 years. So one thing that we're experiencing is a bit of a cool new hardware drought. If you think about how quickly we went from car phones to cell phones to smartphones and now smart watches and wearable devices, a lot of that has really petered off in the last 5 years, and companies are looking for ways to innovate, but they're not quite finding anything that resonates with the public yet, right? This is why we see, the public response to something like Google Glass and Apple Vision being very similar. People just aren't sure what to do with that technology. They don't necessarily want to put something onto their face and then have 3D Zoom meetings. It's not interesting to them, certainly not for $4,000 when they're used to going back in time and buying, a cool new smartphone for like $300. Similarly, we've got a bit of a cool new software drought, right? There's been a lot of advances that people have been excited about, but they're smaller in scale than all of this advancement and innovation we got comfortable with in the 2000s and the 2010s, right? When, YouTubes were coming up in the same generation as a platform like Facebook, and then Instagram bursts onto the scene, it gets a lot of public attention, a lot of public excitement. Something like metaverse feels really intangible to a lot of the public, and it seems to be taking a really long time to get anything off the ground that people might be experimented and actually playing with. So additionally, in this world where we do have a cost of living crisis, people are really conscientious of companies investing millions and millions of dollars in something that is unproven to really be any sort of public good or public excitement again. So if you are a company that has been sitting there building your AI tools in the background, testing these chatbots, testing image generators, seeing what new cool things you can push in terms of computer intelligence, last October was a really great time to bring those things into the public conversation, to open Pandora's box and say, look, we're not 112% there yet. We don't have a gold star, but we're ready to enter into the public sphere. We're ready to start talking to other businesses to see how this technology can advance our everyday lives. So one big takeaway, really the whole point of this half of our conversation today, is that generative AI, the type of AI that has been dominating the public consciousness in the past 6, 8, 12 months, it's really always been in progress. It's always been in the background. The only change is that the public now knows about it, and the public has that initial access to start experimenting with it. So we're going to take a quick pause there, and then we're going to talk about how we understand these tools really from that marketer's perspective, and how we start to roll out some of these tools internally and build that responsible framework. All right, so now that we have added all of that context, we've done some set dressing, let's get more into the nitty-gritty of understanding AI from that marketing perspective. So our focus here is really just how this stuff works. My goal is to define and differentiate some of the different products and technology, helping you all understand how these tools work and how they differ from the types of AI that have always existed in our buying platforms. And then also just a little bit of caution regarding some of the problems we've noticed. A lot of the Gen AI tech is on the newer side. So some of these things are known, some of them we're still discovering. And that is going to help us inform, what comes next. What can we expect over the next year, 18 months, and beyond? But for now, let's take a little bit of a zoom out and just talk about the way we talk about artificial intelligence. So this is really critical context to keep in mind as you're reading news, as you're trying to follow updates from your platforms, from new vendors. It's really important just to keep in mind that this is a broad term that means a lot of different things depending on whom you ask. So the theory definition that we presented up top is still relevant here. Obviously, machine learning has come a really long way. The AI we use in our platforms really blows the stuff from the 50s and 60s out of the waters. But when you're reading news, you're going to come across terms like artificial general intelligence, or AGI. You're going to come across, cautions and warnings about things like paperclip theory, runaway AI. And that's all important context to keep in mind. But as we say to our own staff, especially when we're talking about the concept of AI anxiety, 90% of that is going to be irrelevant in our lifetimes, right? Especially to our daily life and to the tools we have today. So just note that when we're having those hypothetical conversations about what AI could do to specific industries, some of those real harms are present and here today, and we're going to talk about them. But when people go off and talk about Skynet, the Terminator, etc., they're not talking about the applications that exist today, like ChatGPT, Bard, etc. That's still in that theoretical state. So for the rest of this presentation, try to put that in a box in your mind and toss it to the side, because we're going to talk about the next three key terms here that are going to be more relevant to our day-to-day understanding. And the first one in the marketing world is what I'm calling like quote unquote AI, referring to that colloquial way that marketers and marketing technologies have started to talk about AI. It is an unregulated term, just like that, 100% natural you might see at the grocery store. And ever since, that AI boom and that renewed interest has really taken off in the past year, we have noticed at Coegi a really sharp increase in technologies calling themselves AI, but not getting into any specifics. So just something to keep in mind. We should all know this as marketers, that marketers are going to market, but there is that increase in, .ai web domains. There's been an increase in, AI coming soon, flashing across, all sorts of different tools and tech vendors popping up in your inbox with that latest new Gen AI craze. So keep in mind, it is possible to call anything AI. So hopefully with, this deeper understanding of machine learning and Gen AI, it'll empower you to ask a few of those tougher questions, get a better idea of the technology actually being sold to you or that you're evaluating. And really, just our advice is to keep in mind that if someone sort of obfuscates or they don't want to talk about what is actually in their AI or what type of AI is used in their tool, but they're charging you some sort of surcharge or premium for their AI product, don't hesitate to poke at that a little bit and to ask questions. It's been a little bit of a red flag in the past year. But those two little preambles out of the way, let's talk about the nitty gritty, the machine learning and the Gen AI. So machine learning is the more accurate term for the type of AI that's been in our buying platforms this whole time. It allows a program to test and learn without us as human beings having to go in and manually change settings based on its feedback. So obviously that's a huge time saver. It's saved our butts in many, many, many different ways, but especially in the areas of performance and efficiency. We've been working with machine learning or algorithmic co-pilots in our buying platforms for, a decade or more now. And we can expect them to continue building and growing over time. But keep in mind, algorithmic learning or the algorithms that's often used interchangeably. It's all referring to that subset of AI underneath the machine learning umbrella. Now, generative AI is the more specific term for the types of AI that have been all over the news the past year. So this is the technology that is newer, but I do want to emphasize it's inaccurate to think of it as like the next AI or a supplement for machine learning. Gen AI and machine learning are going to continue to both develop and grow together. But you'll often hear the term deep learning when we're discussing Gen AI because it represents the difference in how these things are coded, how they are actually built, and the purposes they're trying to answer. So whereas machine learning relies on algorithms, this deep learning or Gen AI is really going back to that theoretical question of artificial intelligence. Can we imitate human cognition with machines? Can something mimic the neural network that exists in our brains and how our brains store information and retrieve information to answer a problem? So we're going to see a lot more with Gen AI, not just in small companies or applications that pop up, but also just how deep learning is going to coexist with machine learning in general is something we're excited to see. But for now, let's actually unpack that idea of algorithms and neural networks. So our platform learning being our example that we're going to continue with here, that is algorithmic learning, machine learning. So this is really a rough mind map here of how the algorithms within our platforms function. So you're going to have some sort of a data input in the context of a marketing campaign. This is going to be, your live data, the exact same data that you would be pulling if you were to pull a report on how your campaign was doing. But it's also your campaign settings and what we've instructed our platforms to do. This is why a platform specialist is always going to really emphasize having some sort of an actionable, measurable KPI so that we can instruct our platforms and the algorithms that make up their technology what is most important to us, what really matters when they're evaluating, the massive, massive amount of data that comes along with any marketing campaign. Let's see. For our example today, to keep in mind, let's say we're running a LinkedIn campaign. So we have uploaded, our target CRM list of our B2B contacts, and we're asking it to, target these people in the Midwest with the most efficiency possible, right? So we might upload our data set a KPI of reach or an objective of reach, with that KPI being to minimize our CPM. Now, when we give our campaign that instruction, the algorithmic model is going to kick in. And as our campaign is live and it's trying to optimize to that lower CPM, it's going to weigh a few different scenarios of potential optimizations, just like we would. And it's going to do that by trusting its training data set. Now, an algorithm's training data set, in this case, you can think of it like a type of memory. So where we as a human specialist would rely on our own experiences, our own context, our memories, it's going to rely on its training data set to inform any type of optimization it wants to make. So an example of that might be, if our LinkedIn campaign is live in the whole Midwest, and we're focusing on reach, we as human beings would expect that the Chicago market is probably going to be a better focus for our budget than one of the smaller markets somewhere in Southern Illinois. So we might go ahead and proactively make that change when we're setting up our campaign, but if we didn't, the algorithm is going to test that scenario against its training data. And from that, it's going to make a prediction. That prediction being, if we increase our bids or if we shift our budget to that Chicago DMA, we're going to get that more efficient reach that we're optimizing for. We're going to lower that CPM and meet our KPI goal. And that is the logic that informs the optimizations that the algorithm makes for us. But it doesn't stop there, right? Once we have that result, once that change has been made and there's significant enough data for the machine learning to reevaluate, it's going to go through this process of updating its model, updating its memory and that training data based on our results, right? So if that Chicago budget shift optimization did improve campaign performance, next time, it's not going to have to run that scenario. It's just going to know, okay, let's shift some budget to Chicago, right? But similarly, if it is not successful, if, let's say we had a CRM list and nobody on that list lives in the Chicago area, it's going to correct that change and run those scenarios again against some different test markets for us. Now let's compare that to something like a neural network. With Gen AI, your prompt, first of all, is going to be a very tangible difference, right? So while the data input for an algorithm is going to be very structured, it's going to be clearly labeled, this is my emails, this is my cities, this is my creative list. Part of the advancement that a neural network has given is the ability for the AI to add context and understanding to just, human language, that raw language that we speak in when we are prompting it. This is why when reading about Gen AI, you're going to hear a lot about large language models. They go hand in hand. They inform one another. So we are going to input it and prompt it to do something. And that is another huge difference that a neural network provides, is the flexibility of what a generative AI can do, what it can produce. When you're looking at an algorithm, it looks a lot like a math problem. In many ways, it is a math problem. We can expect that results to be similar and replicable and simple and straightforward. Whereas with Gen AI, we can prompt it to create text, audio, video, images. Really, the best comparison I've heard is if an algorithm is your high school math class, Gen AI is like your high school English class, or even like your theater class, right? It's that more creative, it's that more open-ended type of process of creation. Now, once we prompt it something like, tell me a story, write this email, create a video, use this audio to say this, it's going to take a look at all of its training data. But you'll see in this case, we've chosen a 3D image for this training data because it is raw, it is larger, it is much more complicated. One of the biggest advancements is the labeling, like I said. So the data on an algorithm is going to have to be labeled in order for the algorithm to move forward. An example of that might be if you're uploading that CRM list, you have a bunch of emails, but you don't label it email in that, cell A1 in your spreadsheet. An algorithm is not going to know how to read what you've uploaded for it, and you're going to get a failure. Something like a neural network might say, okay, yes, this is unlabeled data, but it all has the @ symbol followed by a domain. This is probably a list of email addresses, and it's going to intuit, it's going to infer, and it's going to move forward, right? But that probability element of this is really, really key to understand with a neural network. It's not just running scenarios and predicting them and testing them. It's trying to do all of that full process before it moves forward with any sort of result creation. So in many ways, where an algorithm is a math problem, it is that straightforward result. With a neural network, it's a lot more like rolling a die every single time we prompt it to build something. So behind that die roll, right, simplifying how these things actually work, you're going to have all of that raw training data within the network, right? Think of this as the memory, but again, it's a lot more like human memories where they're a little bit disjointed. They're kind of all over the place. It's not in one neat little box or one neat spreadsheet that can be referred to. Using its large language recognition, it's going to decide some sort of method, right? What are we asking it to do? What should it be trying to produce when we prompt it to tell us a story or debug this code? And then from there, depending on the complexity, it's going to run a probability calculation of what you are actually looking for. So in the example of tell me a story, or when you're working with a chatbot like ChatGPT, it's taking a look at all of its training data and functioning kind of like a calculator for words, right? This word is heavily associated with this one. This phrase belongs with this context. And that's how it's actually going to build something that appears new. So if you're a visual learner, we've mocked up this sort of sloppy example of what this actually looks like. Let's say we're going with the show me a dog example. So we told it show me, so it intuits from that we want to see some sort of an image. It's going to take a look at the relevant training data that it has access to and try to conclude what you're looking for. So that probability calculation is going to say, okay, we didn't specify very much about this dog. I am looking for least common denominator, like picture next to the encyclopedia entry dog, right? It's going to pull from its training data and conclude that this little image here is approachable, it's neutral, this is dog in its rawest form. But it's not just going to spit out what it has previously pulled from its data, right? It's not just retrieving like a search engine might. It's going to take that additional step of looking at all of the other training data it has access to, trying to determine what they all have in common and what your new output should be, right? So when people refer to Gen AI as producing the least common denominator of its data, this is a way to visualize that. right? Yes, this is our base level dog, but all of the other dogs it has access to in its training data are black and white. There's like 101 of these that have spots. So the result is going to be very similar to this dog, but with, those added changes, with those commonalities from the rest of its training data. So hopefully with this example, you see why it is so important for us to understand what is in this raw training data, right? When different companies come forward with their own Gen AI products, the thing that they are protecting, what is actually proprietary, often comes from how they have told their tools to refer back to their training data and what they have coded them to do from there. So the question of like what's in the box, like yes, it's proprietary, but as this technology has gone public, academics, regulators, other businesses, we're all asking that question, what is in the box and what does that mean for all of the content producers whose information is being used to determine that least common denominator? So, what you're seeing here is some reporting from the Washington Post where they were able to get access to some of the training data that's gone into the biggest models out there today. A significant portion of it is what we would call just general information on the internet, right? It's patent filings, it's Wikipedia, a lot of encyclopedia based information being complemented by news media to kind of modernize or give a little bit of a cultural lens to it. This news media question has come up quite a bit as we discuss things like copyright infringement and paying people for what they produce if you are then profiting off of it with some sort of AI tool. This is why I know a lot of Canadian press has recently banned AI scraping, and they've started requiring more and more that people log in or subscribe. They're paywalling their content more because currently this is a new enough issue that we don't have that societal consensus on whether or not it is moral for these AI tools to borrow quite liberally and just scrape from the internet to inform their tools. Additionally, not only with that news copyright, we've got a larger copyright concern. So we've seen quite a bit of information pulled from places like Kickstarter, right? So if you are, trying to get your small business or your product off the ground, you've uploaded that to Kickstarter, and then later some mega company uses, ChatGPT or some other tool to spark a new idea. Their spark might be your original idea, right? So you're seeing a lot of people express concerns over that. Very similar with Patreon. The entire point of Patreon is to pay small creators for their work. So knowing that a lot of that basic Patreon information up front was scraped to inform AI has raised a lot of flags. And then fan fiction sites are a really interesting one that you may not, sort of recognize as a concern if you aren't, very online. But the entire reason fan fiction is allowed to exist, the reason you can't, sue a fan fiction writer for using Disney characters is because they are not profiting from that art that they're creating. So when, fan fiction is used for large language model informing, which it has been quite heavily, we know from this reporting, it's a great source of free raw text to train your model on. It raises questions not only in Hollywood and among traditional publishing, but really society at large of, okay, how much of this is permissible before it becomes an infringement on someone else's intellectual property? And then similarly, like all AI, the inputs affect the outputs, right? So if we know we have some propaganda, some biased content, that's going to affect our outputs, and that's going to increase, a risk for whatever these tools are creating. So with that in mind, let's talk about some of the things we've noticed thus far, right? Now we are catching up in that timeline to modern day. These are the active discussions happening with some risks that we've discovered in Gen AI and its output. One first thing, and this is truly more of a quirk than, a serious problem, but it heavily associates famous characters or celebrities' names with each other. This is going to be a little less relevant to the marketing world, but it's something to keep in mind if you're using a Gen AI tool for any sort of storyboarding or character creation for your campaigns. This is a very significant red flag for Hollywood. It's a huge part of why AI has become a conversation in, the writer's strike, for example, because we know that it's pulling from the least common denominator of its training data. And we know a huge amount of the training data is coming from, old People magazine archives and fan fiction sites. We've noticed this quirk of character names really being grouped, and not just names, but also basic plot lines or terminology that might only exist in one universe popping up in what ChatGPT spits out, for example. So what we have here in this screenshot, we prompted it, tell me a story about a boy named Harry. And you'll see it's smart enough to know that, because we didn't specify, tell me a story about Harry Potter, it should avoid names like Ron and Hermione, but it still spat out Lily and Tom, which, mega fans in this universe are going to immediately recognize as being suspiciously Harry Potter influenced. Again, with this word trio, that's also very heavily associated with the larger, Harry Potter fan base. Now, if we re-rolled that die, if we said, no, this is not good enough, try again, we might discover the same basic type of problem, but instead it might pull in names like Megan, Elizabeth, William, and Philip, or, oh, I was going to try to do the One Direction members, and now I'm forgetting them. Louis, etc. Zayn is one of them. That's another one. You get my point. So really, this is something we're keeping an eye on. It's not something that's going to be easily fixable. The only way to really change it is to change the input data and how they have learned thus far. Now, a bigger problem, and a term you've probably heard by now if you've been in the AI, research phase at your job for very long, is this concept of hallucinations. Hallucinations is the industry term for how they make stuff up. Like I said, this is a word calculator. It's not a fact checker. They don't understand, truth and untruth. And, just like when, the internet was newer, we had to remind ourselves, okay, we can't believe everything online. In this case, these Gen AI tools do believe everything in their training data set. And their training data set is mostly teaching them, this is probably associated with this, right? So when we ask it a question like, what is the world record for crossing the English Channel on foot? It doesn't have that human logic, that human knowledge to say that is impossible, right? Human beings do not walk on water. It's a pretty big deal. But that doesn't stop it from spitting out something that to, the untrained eye might look like a legitimate encyclopedia post or a news article, right? It's pulled that tone together. It's added some additional facts about, the English Channel itself, but it truly just made up a name, this Christoph von der Ratsch of Germany, right? It created a time out of nowhere. This is a really obvious example, but think about how pervasive misinformation already is online, and now think about the path forward being planned to maybe tweak or replace search engines with chatbot type tools. If we don't have that really vigorous fact checking and some way to prevent these hallucinations, it could create very serious problems. So I have flagged this to several marketers who have talked about, using ChatGPT to generate keywords for their campaigns or to guide, research papers or content that they're writing. You certainly can do that, but you have to be very, very vigorous of not just taking everything it spits out and running with it. You do have to fact check it, especially if you're working in any sort of regulated industries where you might get yourselves or your clients in really hot water. The other thing to keep in mind, kind of circling a little bit back to that input output bias, right? We've known and we've talked about algorithmic bias for a long time. We've talked about how humans can accidentally introduce their own biases in the things that they program. But a big difference with Gen AI is that it's significantly more difficult to repair once that bias has been introduced. Because it is not a math problem, it's a neural network, we can't just go in and change our formula, right? Once it is in the memory bank, it's in the memory bank. So we're seeing this already with, some outputs when you prompt it to show you the history of art, for example. We've noticed that it's very heavily Western influenced in general. Now, this may change as engineers in different countries and different cultures start producing their own tools. But for right now, we do have to keep in mind that most of this technology has been pioneered in the West as it exists. And therefore, a lot of that bias is going to have to be really vigorously checked as well. We truly can't just run with something that's been output. And then finally, another one that's really tough to fix that's been, an increasing point of conversation in these past few weeks. I'm recording this in September of 23. Model drift. Model drift is something that we've known about in algorithmic and machine learning for a long, long time. If you have done any sort of programmatic or automated buying, you've probably experienced it yourself and just not known that this is the term for it. But essentially, model drift is this phenomena where the longer an algorithm is running and learning, the more inconsistent those results start to be when you compare it to the training data, right? So, because it is constantly learning, because it is changing and making those minor tweaks, eventually we start to hit that plateau of effectiveness, and then things can even decrease, right? So if you've ever been running a campaign and have experienced things like audience exhaustion, or your performance KPI just sort of plateaus, you're not getting the results you used to get. Part of the rationale for that is that you've been running with the exact same settings for too long, right? So it's truly not just an excuse that your account manager at an agency is giving you when they say, hey, we need to refresh your creative, or hey, performance isn't doing what it needs to do, we need to make some changes. You truly cannot run an algorithm for 12 months, even 6 months, and expect that performance to always exponentially increase. You do have to go in and make some changes. But similarly with Gen AI, because it has scraped the internet for that training data, because a lot of these tools have gone public and they've had the public going in and teaching them and training them based on, millions of inputs, we're starting to notice that compared to when products were first released last year, the results are starting to kind of plateau. They're not as informative, they're not as reliable, they're not as accurate. And currently, we do not know publicly how companies like OpenAI or Meta or Google plan to address this problem. Again, it's the exact same conversation as the bias conversation. We can't just go in and reset the learning phase of something like a Gen AI tool. You cannot pluck a single memory out of human consciousness. It just doesn't work that way. And that's what a neural network was modeled off of. So this is something we're going to have to keep an eye on. Certainly something that might answer some of your questions if you are a heavy user of Bard or ChatGPT and you've started noticing your outputs are not as exciting or not as cool as they were back in January. This is the current explanation for why. So with that in mind, what is next on the horizon, right? We've had an exciting year of AI developments. We've started throwing some cautionary flags on the field, and we can expect to see this same conversation continuing for quite some time. So first up, more lawsuits and regulation we should expect, right? This is a global conversation. We've got a little bit of an American-centric lens here with these examples. Certainly with the writers' strike and now the SAG strike, it's been a hot button issue in a lot of different industries. And we're really just beginning to have that conversation of, okay, which, roles need to be protected in our society? Which elements of AI harm do companies maybe need to be responsible for? What is going to be left up to the public? And then globally, what do we do if, let's say, the EU disagrees with North America on how they want to proceed with this? We've seen a lot of calls for AI to be something that's handled by the United Nations, for example, because there's just so much inconsistency and there's so much potential for immediate harm, right? Not just sci-fi harm about a Terminator. There's real issues happening currently today that we don't have answers for. Similarly, we can expect to see other global major companies trying to catch up and release their AI tools. So, as we talked about back on the timeline, Gen AI has been something that each of these mega companies have been working on in the background for a very long time. But OpenAI hit that go button, right? They went public with their tools. It's been a large conversation. Their timelines for when they want to release their own products have vastly accelerated to try to stay relevant within this conversation and not just let OpenAI or Microsoft or whomever sort of become that go-to, that owner of Gen AI. And then similarly, as I mentioned up top here, machine learning is not dead just because Gen AI exists, right? We can continue to expect to see machine learning models be able to handle more sophisticated problems. We can expect to see more of our tools working together, having some sort of performance marketing AI focus and some sort of more creative Gen AI focus going together. We've started to see that already this year with things like Performance Max and now Meta's Advantage Plus, wherein we are, cross-pollinating some of that AI technology to better improve campaign performance. So keep in mind what I said back in that little warning phase of there are a lot of AI tools out there that aren't necessarily net new, right? It's very possible there are just like a fresh coat of paint on old tech or calling, something that's no more complicated than an Excel VLOOKUP, some new AI. Do keep that in mind. Do reach out to us for help if you want to vet tools. But in general, what's next is really just a lot to learn, right? It's going to take a while to get the new normal as these tools develop, as they continue to affect our day-to-day. But that's really part of what Coegi is here for as well. We do have an innovation hub. We have a lot of our content testing some of these beta tests we've been able to be a part of. I'll plug this one where we asked 2 of our most senior account strategists to question both ChatGPT and Google's Bard with a lot of the same strategy questions we're often asked as marketers to answer. And we compared their results. It was a really fun shoot. You can expect more content like that, but we also have more hybrid offerings here if you are challenged. Maybe if you have that small team, you need a little bit more of that responsible AI framework. You need a contingency plan for if Congress decides overnight to do something like ban, OpenAI products or TikTok, for example. And some AI Copilot rollout plans. We started as a programmatic agency, so our people have been working with machine learning. We've done a lot of that painful learning ourselves of how to best work with these tools, how to avoid the problems they can potentially create if you're not watching them carefully, if you're not giving them nudges in the right direction. We're definitely here for consultation on that. And with that, we'll close out. So thank you all so much for your time, for your considerations here with the opinions we've shared. Definitely do follow Coegi, sign up for our Loop newsletter to get more of our opinions on AI as these tools develop. And I would welcome each of you to connect with me as well on LinkedIn. But for today, we will close.